Boys and girls, let's take a look at this problem. Um, Eloise is training for a charity bike ride. She bikes 23 and 5/8 miles on Monday and 25 and 2/3 miles on Wednesday. How many miles does Eloise bike on these 2 days? I don't have the ability to go and mark up my problem, but if I did, I would want to jail some details. So I'm going to go back through and take a look at and read through the problem again and find some of the important information. Eloise is training for a charity bike ride. Here's some important information. She bikes 23 and 5/8 miles. I would jail that detail on Monday. And 25 and 2/3 miles. I would jail that detail on Wednesday. Here's another important part of this problem. How many miles does Eloise bike on these 2 days? So it's asking us to find out how much altogether she biked on Monday and on Wednesday. So I've got to decide what operation I'm going to use to solve this problem. Okay, so if it's all together, I know that that translates to addition. So now I need to write an expression that is an addition problem. So let's see here. So she biked 23 miles, 5/8 of a mile. Okay, so that's on Monday. And on Wednesday, 25 and 2/3. All right. So there's my problem that I need to solve in order to answer the question that they asked. So now I've got to take what I know about mixed numbers and apply it to solving this problem. So I know that when I have mixed numbers, I need to look at the whole numbers and the fraction parts. Since this is addition, I'm going to go ahead and pull my whole numbers out here. And I'm going to say, well, 23 plus 25. And I'm going to complete this part. So 3 plus 5 is 8, and 2 plus 2 is 4. So I'm going to sit on that 48 and just kind of let it be for now. I need to now take a look at my fraction parts. All right, so I've got 5/8 plus 2/3. And we know that when we add and subtract fractions, we have to look at the denominator first. All right, so let's take a look. I've got an 8 and I've got a 3. Oh, we also know that when we are adding and subtracting or fractions, we have to have common denominators. 3 and 8 are not like denominators. They're different. So I need to find the LCD, the least common denominator. Well, in order to do that, I'm going to go ahead and list out my facts of 8 and my facts of 3. So let's do that now. All right, so I've got 8. I've got 8 times 2 is 16. 8 times 3 is 24. And 8 times 4 is 32. I'm going to stop right there. I think I've got enough that I can find a common one. Now let me list my facts of 3s. And while I'm doing my facts of 3s, I'm kind of going to look through my facts of 8s to see if I have one that's common. So 3, 6, 9, 12, 15, 18, 21, 24. Oop, I see one. Do you guys see one? Oh, that's a 4. Looks like a 29 here. Let me see if I can adjust that a little bit. I don't want to confuse anybody here. So 24. There, that's better. I see 24 and 24. That's going to be my LCD. So I need to change 5/8 to an equivalent fraction with 24 as the denominator and 2/3 to an equivalent fraction with 24 as the denominator. So let's do that next. I think I'll change it here so we can see that we're making equivalent fractions. So we've got 5/8, and I want it to equal a fraction that has 24 as the denominator. So I've got to think, well, how am I going to get from 8 to 24? Well, down here, 1, 2, 3, 8 times 3 was 24. And whatever I do on the bottom, I have to do it on the top. So if I multiplied the bottom times 3, I got to multiply my numerator times 3. It's the same thing as saying that we're multiplying 5/8 times that fancy form of 1, that is 3 over 3. So 5 times 3 is 15. Here, 15. Okay, so now I've got 15 over 24. Let's now talk about our 2/3. We need to make 2/3 an equivalent fraction with 24 as the denominator. Remember, 24 is our LCD. So in order to get from 3 to 24, I need to multiply 3 times, well, let's see here. 1, 2, 3, 4, 5, 6, 7, 8. 3 times 8 is 24. And whatever I do to the denominator, I have to do it to the numerator. Don't want to make them sad and leave them out. So I'm going to multiply my numerator times 8. 2 times 8 is 16. All right. I have the equivalent fraction of 16 over 24. I'm going to go down here and rewrite my fraction addition problem, because now that I've got my equivalent fractions, I need to kind of focus a little on those equivalent fractions. So 15 over 24 plus 16 over 24. Now let's perform this operation. Oh my goodness, we worked so hard to get these common denominators. Let's keep them. So we're going to keep the denominator at 24. We're going to add our numerators. 15 plus 16 is 31. Okay, I'm not done yet. I can't go, well, I could add 31 over 24 to my 48 up here with my whole numbers, but 31 over 24 is an improper fraction. Remember, it's our elephant on the ball. It's too big. Our numerator is too big for our denominator. So in order to solve this, we're going to make it into a proper or mixed number, I should say. So 24 can go into 31 one whole time, okay? And then let's see here. I take 31 and I subtract the 24 to get 7. So my numerator is going to be 7 and my denominator stays 24. Okay. Now my final step is to take my fraction part that I got, 1 and 7/24, and put it with my whole number part up here, 48. Well, I've got a whole 1 down here, so I need to add 1 to 48 to get 49. And my fraction part's going to be 7 over 24. So Eloise, oh, I don't like that 24. Let me fix it so it's nice and clear. Let me rewrite that part. I have to make sure it looks like we can see it. 7 over 24. And this is miles. So Eloise rode 49 and 7/24 miles all together on Monday and Wednesday. If your problem after you solved it out does not look like this, go into your Desmos and adjust, change it, okay? Make sure you're understanding each step. Break it apart, take a look at it. If you don't, watch how we did it here and see how you can adjust yours so that it looks like mine.